Hello everyone. Can you all hear me? It's 2:30. I don't know if are we live streaming this or recording this? Anyone know? I'll just get started. If someone turns up and decides to make a video of it, then I might rewind 2 minutes and restart. So I'm glad to be here in Kiev today, and I'll be talking about Rapture, which is a library I've been working on for several years now. I'm going to go quite fast and do a few little demos of the things you can do in Rapture. We have you're laughing at all those funny letters. Yeah. So. I don't know if anyone here has used Rapture. I suspect probably not many. So, a couple, not many. Okay, yeah, a few have tried it. I'll tell you what it is. It's actually probably different things differently, and essentially what I want Rapture to be is a set of libraries for doing common everyday tasks in Scala. I'll talk about what those are a bit later. For me, it's very much an ongoing experiment. It's an opportunity to try out new features in Scala, or things that were originally new features, and to try to take advantage of new ways of writing syntax and applying Typesafety. And that's quite a key driving force for me, to try and find, to try and write code that I think of as being the intersection between Typesafety, very code that's very dependent on the Scala type system, whilst presenting that in a way that's easy to understand, easy to read and intuitive. So I'm going to give a talk at Scala Days about what I'm going to call elegance, this intersection between Typesafety and beautiful syntax. A lot of people either have very nice syntax, but the opportunity of failing very often at runtime, or they have very type-safe code, but it involves a lot of types and complicated things that many people don't understand. Someone described it, I think very generously, as potentially the guava or boost of Scala. I would like to aspire to that. It's not there yet, but maybe sometime in the future I can claim that, I hope. So what do we have in Rapture? What are these everyday tasks I spoke about? Working with JSON XML, I think most people here have done some work with either JSON or XML. I/O is something that you frequently have to do. Cryptography. Anyone who's tried to do cryptography with Java will have found that the APIs are not particularly intuitive, and there's some nice wrappers around those. There is an HTML library. I'll demonstrate that later. But I'll tell you why I think it's better and more type-safe than some other things that are out there. And that includes very recent additions to working with CSS and JavaScript. And there's a nice way of building running an HTTP server, so you can serve that HTML. There's quite a nice tiny little library for working with internationalization. In the UK, where I'm from, we don't really care about internationalization. We just assume everything is in English. But this will appeal probably more in a bilingual country, and a country where you do have to be aware of other people speaking other languages. So I'll demonstrate that a bit later. There's a command line interface and nice APIs for working with processes, so shell commands. There's a small library for working with LaTeX, CSV, and very much work in progress. I'm developing a time library. Sorry? Oh, okay. and a small API for working with sending email. So I'm doing all this a little bit differently from how many people do. I tried to encapsulate in a sort of what I'm calling a philosophy, a Rapture philosophy, of a few key things that I think make Rapture different from other libraries. Intuitive, I already mentioned. You should be able to read the code and immediately understand what it does. It should tell you what it's doing. Extensible. There are many different dimensions in which you can extend Rapture. If you work with other libraries, you will often find that they work for some types, but they don't work for the type you're working with or the other libraries you want to integrate with. Rapture gives you the extension points to extend and provide other ways of doing things for different, basically for different types. It is configurable. It gives you many ways in which you can choose how to configure things. It's also what I call unopinionated. This term was coined by Rob Norris. He said that Rapture is the most unopinionated library he's ever seen. What he meant by that is that I don't say, well, if you're using JSON, then you've got to use arguments, or you've got to use something one way or another. One example in particular is the JSON library. I don't say that you have to use any particular JSON backend, any particular parser. Rapture will work with all of the, pretty much all of the JSON libraries out there for Scala. It's idiomatic. Now, idiomatic is a kind of a difficult word in Scala. People often talk about idiomatic code, and different people have different idea of what that is. And in fact, it's very difficult for anyone to write down what idiomatic Scala is. But Rapture does have its own idioms, and that is a subset of the things that you can do in Scala. And finally, but I think most importantly, it is typesafe. And I try to go further than other people do and use all of the tricks that the Scala type system provides to give you more compile errors. Give you more compile errors when things should not compile. When things are likely to fail at runtime, I want to move those runtime failures into the compile time. And as much as possible, I do that by encoding stuff into types and using the type system to our advantage. So I've got these 6 points here. I'm going to talk through each one of these, and we'll start with why I think it's intuitive. And every time there's a little red asterisk, see that? That means I've got a demo, which I can hopefully show you in the REPL. So I want to show you how you can access JSON in Rapture. So we've got a JSON value. Can everyone read this text? It's on the top half of the screen, but as soon as it goes below the halfway mark, people at the back can't see. So hopefully there's enough screen space there for you to see this. So this is just a value representing some JSON. And we can, for example, get the people value out of JSON. I just call .people. I can get the first element from that, and it's a JSON value again representing one of the candidates in the US presidential election. And I can find out what his age is. Now, you'll notice that every single thing I do here returns a value of type JSON. And JSON isn't a useful type. It's not good for working with. You can't, for example, well, I mean, it's basically untyped. We know that it's JSON, but we can't call methods on it, because as soon as we call a method on it, it tries to access that as if it's a value in an object. So what we need to do is move from the dynamic world of JSON to the statically typed world of Scala. And to do that, we just call as and give it a type. And we now have a type, and we can do everything we can do with an int. And you can extract all primitive types, you can extract case classes, you can extract all kinds of collections. So this is this syntax here, I think, is very nice and very intuitive for working with JSON. You don't have to use slashes and strings. And I think it looks how you would like it to look. And the only thing that makes this a little bit longer than something in, say, Ruby, is that you have to specify this type at the end. But we're in Scala, and we've decided that we're going to work in a statically typed language. So there's no way out of at some point specifying this type. So all of these demos will be quite short, and if at some point you find yourself falling asleep, If you wake up, it's fine. You haven't missed much because there'll be another little demo that's completely unrelated to all the previous ones. So here's a completely different one. I can write a URI. I can write a URI representing the Google web page. Now, you notice I used a string context here. You might have seen sometimes you prefix a string with an S, and then you can substitute values in. If you prefix it with URI in Rapture, then it will interpret that as a URI reference. So what can we do with this res6? So let's give it names. I think I'm going to use it later. Well, this is Google. Now, you notice we get an HTTP URL here. Now, if I said, I need to find an example here that I can load up. Okay. So if I create a file, I do that in almost exactly the same way. So I say, instead of saying HTTP, I say file. Now there's a file on my hard disk here, which I can load. Now we get an FS file system URL here. Now this is some macro magic that's going on. It reads the scheme, the URI scheme we're using here, and decides based on that whether the rest of the text is a valid URL or is a valid file, and then returns a different type depending on what it is. One thing you can't do, for example, is misspell something. This is a compile time error. So spelling mistakes in, for example, scheme name will be caught. It's one little bit where there's a little bit more safety that you wouldn't get if you just had that as a string. So what can we do with these values? We've got Google here still. So we can say Google slurp. What that will do is get all the values out of, well, it will download the URL, and will basically put it into the string for you. Now I specified character here because that is the unit I'm slurping. If, for example, I slurped bytes, I get bytes. This is a hex representation of the bytes in there. But it's basically the same command, but we're specifying a type to choose how we're going to read that. So this is basically a one-liner. You can say, for example, like that dot slurp character. Sorry. The thing I wanted to show you first was what I did with the HTTP URL. I can also do with the file, and it's exactly the same command. We've got there's just some values here that were lying on my hard disk. Whatever the resource happens to be, you can slurp it. You can slurp it into a string, you can slurp it into bytes. So the APIs are unified whether you're working on files, HTTP URLs. You can even implement this for Amazon S3 or FTP. There are extension points for doing that. So I showed you file.slurp. Moving on, we can, for example, write what I describe as a multilingual string. I'll show you. So, no, actually, I've got a better demo of this later. There's no red asterisk there, so I shouldn't show this one. Here is an example of HTML. So this is a very simple page. This is an entire HTML page written in sort of method style. So HTML head title, then the title is a string, and then we've got a body, and we've got, for example, there's an attribute there on the p tag. Style is color red. Now notice this is again it is a string context. The string is prefixed with CSS. What that means is that this content here will be parsed to check that it's valid in a sense. You can't just put any old string in there. If the colon is missing, if you had multiple values and there's a semicolon missing, that's a compile time error. It'll stop you before you get there. And then the contents of the page will just be hello world. One other thing that I'll show you later is that the types of these things actually enforce the tags you can nest inside other tags. And it actually implements the entire HTML5 spec, or most of the HTML5 spec, in enforcing those rules. So you can't, it's actually impossible in Rapture HTML to write invalid HTML5 unless you cast, for example. So I'll give you a demo of this one here. So this is back to JSON again. This is an example of changing a value. We've got people here, and this comes up with Donald Trump. Now, what does everyone know about Donald Trump? Well, let's add some JSON to this existing value. I'm going to say, well, we're going to add a Boolean value, angry, because Donald Trump is angry. Angry equals true, and you see we are immutably producing a new value of JSON, which now has the angry true value there. And this is the syntax we use. And I think that syntax is maybe a little bit strange to begin with because it looks like a lambda. We've got underscore dot angry equals true. But you can at least read that and take a good guess as to what is happening there, I hope. Does anyone here ever need to call shell processes from inside Scala? Yeah, a few people. And probably what you do is you create a Java process and pass it some strings. So we can do a similar thing in Rapture, except we just prefix a string with sh, and I can write a one like that. That is the process. That will create the process that won't run it. If we want to run it, we call exec, and we specify if we want to get a string from that result. This is a string containing all of the values that have been returned. Maybe a string isn't so useful, so we could actually specify a list of strings, which will give us one string on each line. So that's what it looks like, and then, for example, we say for print line, and we'll do basically the same output we saw before. So we have different ways of getting things out of processes, in the same way that there are different ways of getting things out of JSON. If I try to get an integer from that, that will return the success or failure case for the particular process. That succeeded. If I did something which failed, then we get a 1 or a higher number for that. We can also, something I did mention, we can substitute values in here. So you can, if you've got some values here, we can well, let's try something. Let's say foo is hello world. I can say echo foo. That just creates the process. But if I execute it and get a string, what will the string contain? Hello world. Now, what if I put that in quotes? Exactly the same thing. Okay, great. What if I forgot closing quotes? Compile time error? Compile time error. Okay. It parses the sh string and decides whether it's safe to. Well, I mean, what it's actually doing is trying to,
What if quote is part of hello world?
What if
there is an unclosed quote hello world?
Good test. Let's try this. Like this. Yeah. So we'll close that. That works, I think, as you would like. So, what the reason it knows about these quotes and whether they're open or closed is it needs to know how to parse this command into separate parameters, separate arguments. Splitting on string is incorrect. There are cases where some libraries will just say, well, if there's a space between these two things, then they're two separate parameters. That's not always the case. So this will actually check that correctly and will escape things. It'll escape values you substitute in. How am I doing for time, by the way? I've used 20 minutes. Okay, I'll probably go a little bit faster. So I showed you extracting values from JSON. We extracted integer, we extracted strings. What if we want to extract, for example, a date? Let's go back to Donald Trump again, who is here, and we try to get his date of birth. Now this looks like a number. In fact, it's a long. That's fine, but what if we want to get a date? Well, Rapture doesn't know how to get dates out of JSON. There are different ways you might want to implement that, so we don't presume how you should do it. So this fails at compile time. But say you want to provide a way of extracting date. You know your date format. So the way you can do that is by extending an existing extractor. So I've shown you can extract a long. What we can do is implicit depth. We can find the extractor. Now what I'm going to say is get the extractor for long, the existing one we've got, and map that. Because the extractor is a functor, it has a map method. And we can say, given that long, let's create a new date from that long. We've now defined a new extractor. Don't worry about the type at the moment, the type is a little bit complicated, but we've got a new extractor, and then we can try that same command before where we get the date, and this time it is happy to extract that date. So I think one of the best ways of defining new extractors is to start with an existing one, and then build upon that, map across it as a functor. I've got an example of this, but I'm not going to show it because it's not that interesting. But if you wanted to extend your URI scheme, if you wanted to provide a new URI scheme, like S3, you could define something like this. Define an implicit class which takes this thing called the URI context. There's a companion object which I'm adding an S3 method to. There's the S3 method. This is like a typical extension method, except it's provided on this magic companion object. So this magic object called URI context. And this is basically the recipe you follow. It's a little bit less simple to do than the extractor here, but we can basically define how we interpret the string that appears in the URI, and we can choose what type we return here. So when you type URI and then quotes and then some scheme you invent, colon and then some text, that will get translated at compile time into an invocation of this method here that you provide, which has the same name as the scheme. And you will end up with an appropriate type for that particular scheme. My friend with Dennis, did you suggest that I did it this way rather than some other way without? Wasn't it? Okay, maybe it was using that. It was a suggestion from the audience at some time I demonstrated this before, and I had a different way of doing it, and this is actually better. I mentioned that you can use different JSON backends, but you can define your own. If you had your own AST or parser for JSON or XML, you can write a type class and redefine that. You can define capabilities on the I/O resources. So I showed you how you can slurp a file, slurp a URL. You can slurp anything that is readable. So there's a capability called readable that works, that's defined for different kinds of resources. As long as you've defined readable, you get slurping, reading that thing into a string or into a byte string for free, and you get many other things for free as well. But you can define new capabilities. You can define deletion. Deletion is part of the API already, but you can define, for example, being able to get the children of a particular resource, being able to find the parents, being able to dereference a path. These are all capabilities that are available on some set of resources, some sort of I/O resources that you might want to use. And you can define new ones as much as you like. I've got a little bit. I've got a slide later on where I demonstrate how error handling works, and you probably know there are different ways of handling errors in Scala. You can throw exceptions, you can return options, you can return try, you can return futures. I will show you how you can define your own way of handling errors in a very custom way. The HTML page I showed you, HTML just happens to be one implementation of a DOM, one instance of a DOM. You can define your own. You can define SVG if you wanted to. Other XML like DOM formats. So we're on to configurability now. One motivation for writing an IO library in Scala was that I think Java made a very serious mistake with dealing with encodings. What Java does is, if you're doing anything that involves conversion between bytes and characters, if you don't specify how you're going to do that, if you don't specify the encoding, what will Java do? Use the system default. So Java, this language that's meant to be really, really portable, it's meant to work anywhere, makes it very easy for you to write code which won't work when you move the code onto a different machine. You can write that code on your machine, maybe use OS X. All your colleagues use OS X. It works fine in your development environment. Then you deploy that to the server, and the server runs Linux. It has a different system encoding, and suddenly strings start to contain question marks instead of Cyrillic, for example, and stuff breaks. It breaks at runtime. What Rapture forces you to do is specify your encoding. No operation in Rapture is allowed to compile that involves conversion between bytes and characters unless there is an encoding specified. And this is how you do it. You import an encoding. You import encodings dot, for example, UTF-8. I mentioned on the last slide we have different ways of handling errors. If you want errors to be handled with a try, if you want your errors to be wrapped in a try, then import mode.returnTry. A mode is a way of returning values and how you process errors. There is the ability to pattern match on JSON in Rapture. I haven't got any examples, any code examples on this, but sometimes we want to match on. So sometimes we specify some JSON we want to match on, and we want all the keys to be present, and we want there to be no additional keys in that map, in that object present. That is exact pattern matching. We can import pattern matching.exact to specify that that's how we want to do it. We can import pattern matching I think it's called permissive, which would not fail if there are additional keys present. So these are choices. Sometimes they're quite subtle. Sometimes they affect just runtime behavior. Sometimes they affect compile time behavior. But what Rapture does is it's taken this decision to use imports as a way of specifying this configuration. And there are others here. We can, when working with files and understanding how forward slashes and backward slashes work, we need to know the platform that we're working on. When we're interpreting a blob, as in a star or star/star, there are different ways of interpreting those. There's no international unified standard. There are many possibilities. When we're working on the command line interface, often we want to get debug output. When you release your application, you don't want stack traces to be displayed in the command line. You want to catch those exceptions and process in your own way. But while you're developing, debug mode will configure your application to work with to provide you the necessary output to help you develop. And all of these are done with imports. And this was a conscious decision. Imports, particularly wildcard imports, scare people a little bit because you don't really know what's in those packages. There could be new types that will shadow other types. There might be even worse implicit conversions. And I decided quite early on that if I go down the route of saying, well, actually imports are dangerous, they're scary, let's not use them, I constrain myself so much that I can't do half the nice things I want to do. So instead, Rapture makes the decision to go all in with imports. And it says you as a developer need to be aware of what's in these packages, and you need to get familiar with checking the packages, checking the list of imports to see what is being pulled in. Because the benefits, in my opinion, outweigh the disadvantages. So it's more of a change of habit. Expect to find implicits in imports. And the way I make this maybe a little bit easier than it could be is by giving these what I hope are very intuitive names. Pattern matching .exact, glob interpreters Unix. If you're using a glob, quite possibly glob interpreters.unix, that implicit is going to be relevant to what you're doing. I've got one example here of how this might work. In Rapture's currently very basic time library, we can create a date, and the way we write a date is like this. That is a date, and we get that value there. So first of all, it's quite a nice way of defining a date. Now, when you want to print that date out, we want to print it as a string. So we say date.format. Well, that doesn't work because it hasn't been told the format for printing the date. So let's import a date formatter. So what we need to do is import date formats dot. Now let's go with long European. We've now got a date format in scope. We call date format, and we get the string here. If we went for short US and we tried exactly the same thing, we get a different format with, and the American format is to put the month first, so 3/15/30. So this is an example of using imports to specify or to configure how something behaves. So on to what I consider to be the crux of idiomatic Rapture. It's this one key thing is this use of implicits and imports for configuration. Now, I've also said scoped configuration. One important thing about implicits is you can define their scope. If you have an import inside a class, its scope is the entire class body. If you have it inside a local method, it's just the extent of that method. You can decide the extent or the scope within which the implicit applies, and this gives you a lot of flexibility. You can even define implicits in the package objects and have them applicable across many different files that all exist inside that package. And this allows you to basically specify the extent of that configuration. Many things are global, many things are local. You get the choice of implicits. You just decide where you want to import them. So one other idiomatic feature of Rapture is that it uses type classes for most of the things that are extensible. Who here is familiar with how type classes work in Scala? So probably half, maybe a little bit less than half. So type classes, I probably haven't got time to explain them right now, but they give you, through a combination of implicits and defining interfaces and then implementing those interfaces, they give you ways of, rather than specifying capabilities of some type and all its subtypes, they define capabilities of some arbitrary set of types that you can define. And you can extend that after the fact. You can create new type class instances that allow you to add functionality to some particular type later, after the type's been defined, after the interface has been defined. Whereas with inheritance, which is more familiar to people coming from Java, you can't retroactively change a type to inherit from something else. So type classes are much more flexible. They give you much more, or many more possibilities for extending in different dimensions. And Rapture uses this throughout with all these models. Rapture has very precise exception handling. I haven't got a demo of this, but I did do a talk about a year ago at Scala Days on how it allows you to know with some certainty what possible exceptions a method can throw. Normally, Scala doesn't track exceptions. It doesn't have throws like Java has. Rapture kind of implements throws in a way that isn't annoying as it is in Java, because you can turn it off and on. You can decide when you want to handle things, but you can have the compiler help you check that you are handling all exception types. Now this is a very vague and general idea, but as much as possible I use types instead of values for things. I've got a demo here. What I can do is I can define an internationalized string. So I'm going to call this message. Now I want to have an English version, which is going to be hello. And let's have a French version of this string, which is bonjour. And let's have a German value, guten Tag. And I'm combining these three things. They're all strings that prefixed with the two-letter language code. And we get this value here, which is of type I18N, internationalization, of a string. And then encoded in the type of this value are all the languages that appear there. You've got English, French, and German. And this is just the two-string representation, which doesn't show all the languages, it just shows the first one. But it does tell you what other languages are in there. So with this message, what we can do is we can apply type to it. Not a value, we apply type to it, and we can get that out as a string. We can do that with French, we can do it with German. Now, why would I use a type rather than using a value? Well, it gives us more information at compile time, because if I try and get the Russian version out, there is no Russian version. So this is a compile time error. We know at compile time that this map, because it's essentially a map from a language to a string, the map does not contain this value, and we don't have to wait until runtime to find that out. We know straight away. And you probably saw there that I used the with type. It's English with French with German as the type. I'm increasingly using intersection type, that's this with type, to represent something that is a bit like a set of types that exists at compile time. The parallel with sets is that a type that's A with B is the same type as B with A. Dennis is shaking his head because of linearization. But the compiler will consider them the same. It will consider.
One is not the subject of the note.
One is not the subject, but one is acceptable as a. So you can use one.
Different type numbers. Yeah.
Oh, but in this particular case, they don't have any type numbers.
Yeah, but the compiler can have something they can.
Well, so I can, for example, say message I18N, which is a string of English with French with German, equals message. Oh, sorry. Round message 2. That works fine. If I reorder it, it's also fine. Did you miss it?
Yeah.
The compiler is completely happy for me to reorder them in the same way that the order is not relevant to the set. It's also happy for me to duplicate things, so English with English. That's also fine. So deduplication of types and reordering works fine for intersection types, and this is a parallel with sets. So I'm increasingly using sets or compile time sets in Rapture. The other thing is that you've seen several examples of already is macro-checked string contexts. Getting compile errors from something that's in a string prefixed with a couple of letters to say this should not compile because the structure is wrong, it doesn't parse, and that's used in several cases. This is kind of idiomatic of Rapture. So the idea behind the library being unopinionated is that you have a lot of choice in for example, which libraries you depend on, which I've given the example twice already of which JSON backend you depend on. You might have different reasons for working with Argonaut or Circe or Jawn. Maybe, well, I think I've got some reasons here. Dependencies. Maybe you already have a dependency on JSON for S, so you want to use the JSON for S backend for Scala. Maybe you have an incompatible version of JSON for S, and you want to use something different in Rapture, so you depend on Argonaut, say. Bugs, features, maybe there's a known bug that's exhibited in one library, and you need to just swap that out for another one. That's just an import change. You import different backend, and it will work the same way because you're using a consistent Rapture API, but behind the scenes, it's using a different parser, it's using a different AST to represent your JSON. The licenses might be incompatible licenses. This matters. You don't want to release a library that has an incompatible dependency. And for Rapture JSON, which is the best example of how you can swap things in and out, there are actually 8 different backends. You can import Jawn. Jawn is Eric Osheim's JSON library. Circe is Travis Brown's. Argonaut is Tony Morris's. Play. I know all of these. I can keep naming people, but I don't know who did Jackson. It's obviously comes from Java, which is probably why I don't know. But these are all possibilities. And what I intend to do is provide the same thing with, for example, working with type, working with cryptography. You might want to use, I don't know if you know Bouncy Castle, which is a crypto library. You might want to use a backend which, this is a particularly important example for cryptography. You maybe want to use a backend which has been verified and validated by some authority that does these checks. And because you have a legal requirement to depend on a verified crypto backend. Different web servers, different XML backends, logging. All of these are possibilities. Some of them are in the process of being implemented. Some of them are merely future ideas. When you're working with ScalaJS, and a lot of Rapture will compile already for ScalaJS, you might want to bring in different dependencies which themselves are compatible with ScalaJS to avoid putting in dependencies which aren't. This is a big issue for ScalaJS. Obviously, you can't just depend on JVM code. It needs to work for ScalaJS. So we can have different backends for that. So on to what I think is the most important part of Rapture, Typesafety. This is an example of a JSON literal. Cool. It's another string context, but we can write a value here like this as an object. Foo. What was foo? I can't remember. That was a string. Okay. Well, let's create a JSON value. Foo. I can put that in there, and we now have that substituted into JSON. If, for example, I left off this close quote, it's a compile error. If, for example, let's say I had some type, an exception. I'll just create an exception there. Let's try and put an exception there. That's a compile error. You can't substitute an exception into JSON. It just doesn't make sense. We don't know how to serialize that. So all of this is checked at, in fact, also that it wouldn't pass, but it's unable to convert this to JSON. We can do a similar thing with XML. So food, we've got a food type here, let's have bar in there and baz. Does that look okay to everyone? Okay, and the compiler agrees because it expects a closing tag for baz, but it gets food, and we need to close baz like that, and it's happy. So I was very pleased when someone told me that actually they had a load of code that was in production, and when I added this feature to Rapture, they went and just changed all their strings to JSON strings. They prefixed them with JSON. And Rapture came back and said, well, you've got an error in this code. Now this was stuff running in production. As it turned out, they hadn't actually run through this particular, they hadn't produced this JSON anywhere where it had gone out into the wild, but it found an error that had existed in production code for some period of time, and they were able to remove it. This is a new feature I added last week. We can also have JavaScript in a string. So function, let's do, I think that looks like valid. JavaScript, again, it will parse it. It'll check if you write something that's not going to work. So this is used by the HTML library. If you want to include some JavaScript in an HTML page, you have to provide the JS type. This JS type here, which means it must have parsed in order to be substituted into the HTML page. I've got an example of the HTML5 rules being enforced. Let me show you that. I can create a page, HTML head. Let's create an empty title, body, and table with a T body, and I've missed a. This isn't working. This was meant to be an example of one that does work, but it should work. Oh yeah, okay. So this is you spotted, or the compiler has found the error, which I couldn't find. This is perfect. It's worked better than I expected, as long as it works this time. And I saw an extra one there. Okay, so this is unwittingly, this is an example of Rapture catching a typing error, as in keyboard typing error. This is all fine. It's happy to produce this HTML here. But if, for example, I try to put an image inside a table, we get a compiler. The compiler at the moment is not very helpful. It's difficult to see what the problem is. But I've got a cool trick which I think will give you much nicer errors in these cases. But that's work in progress. Encoding structure in types. This is probably the most advanced typing that Rapture does. Rapture has a command line interface. It allows you to specify a command line for a shell command that you might want to parse. So you can define parameters like this. You can define alpha. This means you have a string parameter which would be applied on a command line with -a and then a string, or --alpha. That's my definition of alpha. I've got one for beta. Beta takes an int, and we get this here. And I've got gamma as well. So these are all really, I mean, they're called simple parameters. They're sort of positive style parameters that you call in the command line. Now, a whole command line will contain several things. Certain parameters should be present. Certain parameters should be present if others are. There's dependencies between them. And maybe we want to say something like alpha. We either want an alpha parameter, or we want beta, and gamma. So this is the specification. Either you call this command with beta and gamma, or you call it with alpha. These are two possibilities. And if we just compose these values representing parameters like this, we end up with a complicated type. This is all, so this is all the type. But you'll see that the type is referring to beta, it's referring to the singleton type gamma, and referring to the singleton type alpha. That structure, which I've defined in this value level expression here, this very simple value level expression, gets encoded into the type. And given that, if I say, for example, I have some params, this is, for example, an example of something someone typed into a command line. This is what params value is representing. I can take this value here and I can say parse those params, and it will parse them. This will either succeed or fail. There's always the possibility it will fail. If you provided only beta, it would fail. If you provided some other completely random parameter, it would fail. But in this particular case, it succeeds. And the value we get back is still encoding it's encoding that structure. Beta, gamma, and alpha are all present. But what we know now, because this is because this has been parsed, we know that we know that it's successfully parsed. So we know the value that's inside there, the runtime value. Given that this exists, it must conform to the complex type structure that's in that type. And what that means is, if we handle all those cases, if we handle the case where it's alpha, and we handle the case where it's gamma and beta, then that will definitely succeed. It is a total function. And we can check all this in the compiler. So what this means is that we have one line where we parse a list of parameters, which can fail. There's one possible failure point, and everything after that is a total function, and it's safe. So this is a really nice place to be, because you handle the errors once, either with one line passes or it doesn't, and then after that, you're safe, and the compiler is checking that you've handled all cases. You're only accessing values which definitely exist. But this is quite advanced. I've explained it to you very, very quickly. There's a whole talk on this, which I gave at Scala World, and that's on YouTube if you want to search it out. And then type factor internationalization. I've shown you this already, but let's give you another little demo. Let's create our message again. Let's specify that it's going to be an internationalized string with English and French and any languages anyone knows here? Greek. Let's go with Russian. Did you say Greek? I don't know if someone did say Greek. Is GR the code for Greek? Okay, let's do Greek. Why not? And okay, let's put a string here. Someone pick some.
Cheers.
Sorry?
Cheers.
Cheers. Okay. Cheers. Oh, let's say cheers everyone. Okay. Oh, not found type GR. Is Greek not GR? Let's just go without Greek. Sorry? What? Okay. Is that UA?
No, UK.
It's UK. How confusing. Okay. So we get the error message saying some language translations were not provided. French, Russian, and UK. Now what this is saying is basically you can't instantiate this value, because the type says it's got English, French, Russian, and Ukrainian, but obviously we've only provided English. This is a problem, and it's a compiler error, consequently. We know that if we've created this message, we want to be able to apply a type to it and guarantee that works. So this is correctly stopping us. So what would you normally do at this point? You would probably write down the Ukrainian Russian word. but how many people here know French? Okay, so you'd probably go to Google Translate, or you just import Google Translate, and then try the same thing, and it will go to Google Translate and say, well, acclamation tout le monde, and then it will also give you Russian as well, which is Vesely Psir. Is that right? Vesely Psir. Close enough. And Ukrainian is the same. Is that correct, or is that a gross approximation? That's okay. Do you want to just try this with a different word? Anyone got a more exciting phrase than cheers everyone? I didn't hear that.
Thank you. Just thank you.
Thank you. Okay.
It's different. Thank you.
Okay. So. Well, okay, so this is, the French is somewhat longer than you would typically use. Spasiba and, two vowels in a, I mean, I can't pronounce Ukrainian anyway, but two vowels in a row, I can't. So someone tell me what it is?
Yaku.
Yeah, oh, okay, Yaku. It's almost like English. So this is it's kind of a novelty feature that you can. We're using a macro to work out which language is provided and to give you a nice error message. And I figured that, well, if you've gone that far, if the macro has looked at the types and it's worked out that you've missed some, then why not just work out what the correct text is? So I just sent an API called Google Translate, and it works it out and reports it. So I haven't implemented language translation in the compiler, but Google have implemented that, so I just use that. I've got 3 minutes. I'm going to rush through the last couple of slides. We have modes in Rapture for handling errors. So this is the possibility of returning a different type, depending on how you want to handle errors. So there are options like option, try, future, and Rapture provides a type called result. With result, you can accumulate errors. In fact, I'll do this demo. So accessing values in JSON. Let's go back to Donald Trump again, and we've got the name there. Let's try and get his name as an integer. Now, we would expect this to fail, right? Fail. It's a stack trace. That's the default. In production, you probably don't want exceptions being thrown. You want to handle them in some way. So what we can do is import modes.return try. Let's try the same thing again. Exactly the same command, except this time we get a try. What if I choose return option? Same thing. We now get none. None is the failure case. Let's try it with Rapture's own results type. So we import this mode, same thing again, and we get a thing called errata. Errata is the error that occurred. It's equivalent to failure in try. Except, errata will give you possibly many exceptions. It will accumulate errors. So if, for example, we defined a case class, well, let's just call it foo, and it's got an int called bar and quotes, which let's call that a string. So I've very quickly defined some random case class. Now let's try and get Donald Trump's name as a foo. Now this will fail again. But because we have results, we actually get a list of all the failures. Now you could, for example, do this across a whole list of JSON values, a JSON array, and it would tell you, for example, that well in the first element you've missed bar, in the 10th element you've missed quux, and it will specify exactly the places you need to look to fix the errors. So this is quite nice. You might get thousands of errors, and it will just collect all of them up. I mentioned before that we have method signatures encode the types of exception they throw. Now, we know, for example, that the type of exceptions in this failure are data get exceptions. The return type is encoding the types of exception that can happen there. So if you wanted to handle all of the possible failures that could result, or that could be in a result coming from a JSON access, the compiler knows that you have to handle data get exceptions. So if you've handled that, then everything's good, and you know that you've handled all the possible failures, and therefore you must have a success. So this is the benefit of encoding the throws type in the return type, and it allows you to write safer code. It's more work, but it's work that's helping you to write safer code. This is a bit like checked exceptions in. I've got 50 seconds left. This is a bit like checked exceptions in Java, but of course you can just import a different mode if you don't want to use this. If you just want to have exceptions thrown, import the standard mode, and you don't have to worry about doing it. So that's the end of the detail on Rapture. So there's a lot of people, well, there's a few people using Rapture, and they love it. Most people don't use it, and therefore most people don't love Rapture, but they may do in the future. So I would like you to try it out. Bear in mind there's a lot of experimental stuff in there. There is an issue tracker, which has currently about 45 bugs, but the bugs are annotated and maintained, and they're all assigned to me. Some of them are marked as easy, which means that somebody else could come along and work on them. I'm often in the Gitter channel, the Rapture Gitter channel, so pop in there and ask questions if you'd like to contribute. You'll be very welcome to. I've got some reasons why Rapture is maybe not more adopted, and things I need to do, but and that I'd love to have you contributing. The web address is github/repentive/Rapture. Have a look there. The issue tracker is active, and that's everything. Thank you. Have I used up all my question time? Yeah. Okay. I'm around the rest of the day, so come and find me if you want to ask questions, and I can do demos and things. Cool.
Use it in production?
I use it in production, but my standards are lower than most people. Thanks.
The result is from your
Yeah.